All right, working on chapter 1.8, we're just solving a variety of equations, some rational equations, some quadratic type equations, higher order equations, and some radical equations, kind of just cleaning up the loose ends here. Now, when we look at our first equation, x to the fourth minus 9, is actually the difference in two squares. It's going to factor very similar to x squared minus 9, x plus 3, times x minus 3. Not sure why I wrote that as an exponent. Only instead of using the x here, we will have the exact same factors if we use x squared. So basically we're looking at x squared, all squared, minus 9 equals 0. X squared to the second power is x to the fourth, so this is just a way of noting that instead of factoring with x, and the way the book says it, it says u is equal to x squared, so we could rewrite this as u squared minus 9. Now it looks like a quadratic. Go ahead and do our factoring, and then at the very end we're going to replace the u with the x squared. This is a really common technique that you'll see as we move into higher mathematics. Okay, so the book asks us to find all real solutions. And so now what we have is we have that property of zero product that basically says that this is equal to 0 and this is also equal to 0. Now, on this problem, I'm going to break out both of those and solve them. X squared plus 3 equals 0, and then x squared minus 3 equals 0. Just going to go through essentially this similar solving steps. Okay, so I get x squared equals negative 3, x squared equals 3. Well, when I take the square root of both sides, on the left-hand side, I get an imaginary number, not real. And on the right-hand side, I get a radical. So my only real solutions for this problem are x equals plus or minus square root of 3. And note that if you're solving an x squared plus any number, it's never going to have real solutions. You're always going to, in your solving step, get a negative under the radical. So you don't even have to work with that. I'm just showing you how that turns not real. Okay, moving on to example 2. A tough little problem. Now we're going to use the same idea in that, and I'm not going to use the u substitution here. I know that if this is factorable, that I'm going to have an x squared here and also here. Now, this is not a pretty factoring because of that 4 in front of the s squared. I guess I should write it as s's. So my AC factoring, I'm looking at 4 times negative 3, which is negative 12. And that means that I'm going to not do that. I was trying to move this because I really want to add an extra step in here. All right, so factors of negative 12 that'll give me positive 11 is going to be a positive 12 combined with a negative 1. So instead of aiming at that negative 11s squared, I'm going to aim at something a little bit easier. Positive 12s squared minus 1s squared minus 3. So here's what I know. One of my multiplications has to give me, so one of my multiplications has to give me 12s squared, and the other one has to give me a negative 1. So the only way that's going to work is if I start with a 4s squared here. Boy, that is not clear. And a 1s squared here. That 4, when I multiply it by a positive 3, will give me my positive 12s squared. And now I just have to figure out what I multiply 1s squared to get a negative 1s squared. And I'm factored. Stating my solutions, Because I have an s squared with a positive here, I'm not even going to bother. That will not be a real solution. But I do need to go ahead and solve this equation. Actually, I can factor it. I don't need to solve it. It's a difference in two squares. You could solve it and get to the same two solutions. So 2s plus 1 equals 0. 2s minus 1 equals 0. All right, I get s is equal to plus and minus 1/2. And we are done. I'll see you on the next video.